Yeah.
Once I was thinking by analogy that there was a time in the 1900s when the thought that the properties of substances were not physics. For example, they would be numbers. We would find a series of numbers, the index of refraction, that was physics. But the number for the index, that glass had an index of 1.543 and so on, that salt had another index, that those numbers, the properties of substances, would come from chemistry or something. But that it was that time, it was considered a different branch. Then when the quantum mechanical understanding of the atoms was evolved, then we could calculate all these properties, and we realized that all these numbers were really part of physics. And so properties of substances became a branch of physics, whereas previously it was a sort of chemical branch. Then I wondered by analogy, and I was always worked by analogy, what today do we not consider part of physics, which may ultimately be part of physics?
I see.
And I realized immediately something. We consider, at the present moment, most people consider that we study the laws of physics, that is how things go, given a certain condition, how the things behave after that. But how did they get into that condition is considered another problem. In other words,
boundary conditions.
Right, boundary conditions. We are given the conditions, the circumstances, and then it evolves from there according to physical laws. We're studying the laws. It's as though we were doing a chess game again, and we're working on the rules, but we're not worrying about how the pieces are supposed to be set up on the board in the first place. That's not our business. That's the business of history, how the world evolved. Astronomical history, history of cosmology, how the universe exploded or the steady state or whatever it was. It's not our business. It's interesting that in many other sciences there's a historical question, like in geology. The question, how did the Earth evolve to the present condition? In biology, how did the various species evolve to get to be the way they are? But the one field which has not admitted any evolutionary question is physics. Here are the laws, we say. Here are the laws today. How did they get that way in time? We don't even think of it that way. We think of, well, that is that way from forever. It's always been like that, the same laws, and we try to explain the universe that way. So it might turn out that they're not the same all the time, and that there is a historical evolutionary question.
But how do you see it going? It's hard to speculate. Is it a continuous change, or is it something that depends on big...
You're the speculator. See, you and I think differently. I think of the possibilities, but I'm afraid to put things in. When I see the dark, I always figure the dark as too big for me to guess at. To guess, it's not much use in guessing particular things. But you're different, and I would like to discuss with you sometime how do you do that, because I'm really a little afraid to make specific guesses.
Is your background?
I don't know.
The way you kind of grow up.
I don't know. I'm afraid to make specific guesses because the moment I'm making that guess, I can see 7 other alternatives. And so since I see these other alternatives, I don't know which one to piddle with. I don't like to spend a lot of energy on one.
My choice is very simple. I don't set any requirement that the answer be right. It's just what I'm interested to follow.
That's the difference. That's the difference.
Yeah.
Well, I'm trying to find
If I'm interested in...
I'm trying to find out not how nature could be, but how nature is. See, what's right.
Well, I don't think you'll ever find it, you see. I don't think you'll ever find it.
I see. And your idea is to find out what nature could be. Different possibilities.
What I think is interesting. Yeah.
Even if it's wrong.
Common ground is enthusiasm.